Welcome everybody. So this morning I was mentioned about the powerful of what you can do with the Gdal PKTOOLS. So now we are going to see Gdal in the morning and PKTOOLS in the afternoon. For the people that are live streaming, and I think that there are already few people, you can go directly to this URL that is pointing to this, okay? So if you just type that URL and it's point to this, and this one is also the one that is available in the Google Calendar inside of the summer school. So you have different way to. So try to organize your machine in this way. So of course over here you can open Firefox. Over here you can also open the terminal. So this we are going to do a bit of copy paste on the terminal on Firefox, at least in the beginning. So the terminal, please just interrupt me if you have question or you cannot follow along and so on. The terminal is really the end core of the bash, you know. Bash is the born again shell, is the language of Linux, okay? So if you are using bash and you are really communicating through the with the operating system, and there is nothing between the operating system and you. So there is only your speed of keyboards writing, okay? So all the command that they are working over here, most of them they have also similar in C, in the command line of C, and you can also use it inside to Mac, because Mac is Unix based, but with a different interface, so you can easily use it. And of course ls is listing all the table, all the folder and file that you have. You can now also access to for example to the home by open the tree hierarchical over here, okay? So just before to go inside to the Linux virtual machine and terminal, I want to briefly show you why using OSGeo. OSGeo is really, you can just Google it, OSGeo-Live, and you will get perfect the same that I give to you, but without PKTOOLS and without the data that I'm going to use it. But for the rest, it's perfect the same, okay? So over here, you can see there are all the software in GeoSpatial that are present in this virtual machine. You can go from browser client like GeoNode, GeoExit, GeoMoose, Leaflet that was presenting, OpenLayer that was mentioned from somebody, the database, for example, the Raster, very useful for data cube in a multidimensional space, Postgres, PostGIS, Spatial Light, and so on, and several one, desktop GIS that we have been using from some presenter also, GrassGIS that has not been presented, but I have lecture that I can point where they are, QGIS and so on. So the beauty of this is that everything is already pre-compiled and you are ready to use it. Okay, so okay, so if you arrive to this web page, okay, you can follow also the installation procedure in this how to install PKTOOLS and how to install OpenEV. You don't need to click, just to reference later on. And also for the people that are following me in streaming, you can download it directly, the data set over here with wget. So again, for the people that are following here in the class, you don't need to do all this step. So we are going to use, let me zoom in. And please let me know if it's quite big. Okay. I'm going to use copy paste because there are really few commands, and I'm going to explain each single step. We are not going to see a full scripting procedure like we saw so far for downloading the table, create a model, prediction, and so on. But we're going to see command by command how to use it and for what you can do it. Then, of course, you have to glue it together to do your analysis. So when using Gdal, if you just Google it, Gdal, you arrive to gdal.org. That is the main page of the command line. Okay, so Gdal is behind all the software that are dealing with geographical information system. So private and open source is really the backbone of your pre-processing analysis. That's why also R is using RGDAL for reading and writing raster and vector file, okay? So you have many two kind of part in Gdal, the rasters, so for writing matrix and for writing vector. Okay, the raster drivers, they can open all the different master matrix layers. So for example, someone last day was saying, can you open map file? Oops. Can you open map file? It was something that I never heard about it. And I say probably Grass can do, Gdal can do it. Indeed, the dot map can be opened with raster file. And the same is for the vector file, vector drivers, where there are all the different vector formats like shapefile, CSV, JSON, S3 object, and so on, CAD, AutoCAD, and so on. So by Gdal and OGR, you can convert the different format and so on. So this is for the writer, but what you can do it with the different command line. So the command line are divided in two big groups. The one that are dealing with the matrix, so with the TIFF and raster file, and the one that are working with the vector program. And this one is something that has been adding recently. So I didn't test so much, but is in the multidimensional, so in the data cube philosophy that we were see together. So I will focus mainly in the one for raster data process and a bit less for vector. Why? Because with the raster you can do really the massive data computation, rather than with the vector it's just a final product from the raster that you can do it. And most of the time, when you have a vector, you just convert to raster for the massive integration in the data cube. So what you can do it with Gdal, you can do it all the different pre-processing that you can do with that you are usually do it in a raster file, like cropping, change projection, calculate minimum, maximum, convert to vector, making some map algebra like band 1 times band 2. You can fill no data, you can do some Gdal edit in the metadata and so on. So let's view a few of them, and then we will go in the really command line session. So for example, one of the most important one is the Gdal Info. Okay, so what you see over here is the typical, so you are very used to the bash, to the R syntax that is quite different from the bash syntax. So in the bash syntax, you have always the command, then whatever is between square brackets, please pay attention, whatever is between square brackets is optional, okay? And then whatever is without square brackets, like this one, has to be there. So in this case, if I ask Gdal Info my dataset name, I will get the metadata, the info data of my raster file, okay? Everything that is between brackets is optional and give you, is also called flags in the bash environment, and give you additional flavor of the command that in according to what you are doing, you can use it. Here the command, the manual is very brief, sometimes it's a bit hard to understand, but after a while it's becoming very useful. But you need to just transfer your knowledge in R and try to see what and how do it under Gdal. So for example, if you do just Gdal and my down, most of the time, not always, unluckily it's not like R. If you scrolling down in one command, you get the example. So for example, if you do Gdal Info, this is my TIFF, you can immediately see the metadata. So the beauty of this is that Gdal is not opening like raster. It's not importing in the memory. This is something very important that is useful for understanding for the massive data process. So here you can see immediately the size of your matrix. You can see the all the projection information, okay? And then you can see also the extent of the file and the pixel size. So these are the most important stuff that even before to open a file, you should be able to see. I mean, you should be asking to the file. So you can immediately see, okay, is a UTM, is not a degree, is so this 60 probably, no probably, is going to be 60 meter and not 60 degree. And it's going to be not so big, so I can open with a browser. Actually, it's very small with an overview. So these are one of the most important one. Then we have Gdal Translate. Gdal Translate is for going from TIFF to NetCDF, from NetCDF to TIFF. All the raster combination that we see is possible. Somebody again was asking me dot map. You can go from dot map to dot TIFF and so on. In the meantime, you can also do a resampling of this data set. You can cropping. You can crop based on lat long. You can crop basing or pixel position. So from the 10 line to the 20 and from the 10 to the 20 row. So you can crop in different way. And then in this case, you are going to put input of your TIFF that you want to crop and of course the output. Again, these are the compulsory, so you have to insert, and these are the ancillary flag. So, and this one, again, check it, always try to read carefully about what you can do it. Let's see if also here there is a, yes. So for example, in this case, the order is not an issue, but most of the time I used to put input and output over here. So I put all the flag first and then input and output. So for example, here is going to use it a TIFF, okay? And it's going to be apply a mask for band 1, band 2, and band 3, okay? And it's going to be output RGBA. So probably this one is something, is a file with 4 band, and is going to use it, this one as a mask, and 1, 2, and 3 band as band for creating the RGB. Anyway, with example, we can see carefully. Something also that you really need to take into account is the compression algorithm for compressing the GeoTIFF. Okay, so this is also option that when you do write raster in R, you can also set in all these parameters. They come from Gdal. That's why you can set it in. And this one making the compression, that are different kind of compression, making a lot of difference in size of the file. So always compress your TIFF, especially if you are working with big file. And the compression can be 10 times. You can have 1 giga, 100 mega easily. Okay, so we can see some information. So these are all the flags. There are plenty of them. So always try to read carefully, and especially for this one, the one with the CO, there are all the different flags. For example, this one, photometric YCBRC, I never use it. So in case I need something with the photometric that I don't know now, I need to read the file. And also there are some additional configuration flag that you can also use it to give a bit more, even more flavor. So Tom, for example, was mentioned about several times about the TIFF for cloud computing. So for the rendering, fast rendering. So these are being done with all these options for cloud computing, streaming, cloud rendering, for cloud rendering for a TIFF to the WebGIS. So another one very useful is Gdal warp for image resampling, also change projection. So when you go, when you go from WGS 84 to UTM, you have to do a resampling, and of course you have to define the pixel size of your output, and you need to check also which kind of algorithm for the resampling. So if you want bilinear, cubic, average, nearest neighbor, and so on, you have to specify input output. In the same time, you can also cropping, okay? Cropping based on the X mean, Y mean, X max, Y max. So be careful that sometimes they invert the position of these. So it's always good to go back and so on. So some of you, for example, use build VRT or use VRT in general. One question. So the question was, can I interface a TIFF files, and in the meantime that I crop it, in the meantime that I warp it, I can crop it based on a vector file. They insert recently one of these cut line data source. So the cut line data source, if you give over here a vector file, is going to warp in the raster, but output only the one belong to that vector file, okay? You cannot warp from raster to vector directly or other way around, warping a vector to raster, but you can do in two steps. So vector, you can transform to TIFF with the Gdal rasterize. When it's becoming the raster, then you can warp it. Or you can do the opposite. You can warp it first in vector, and then from the vector, you go to raster. So some of these kind of requests, you have to do is not only one step, maybe it's 2-3 steps. Okay. So the beauty of these that they give you like 10 commands, but then if you combine correctly, you can then you can do it several operations, hundreds of operations. Okay. So very good, this kind of question, because help you because when you see only a single command, is easy to use it. But when you have to do in this kind of stepping procedure, you have to, okay, I need this one rasterize first and then change the projection. And of course, you cannot find a tools that does immediately what you want, especially if it's a bit complex, okay? So it's good to have this kind of, so feel free to do it. Yes, ma'am. So Gdal rasterize is for going from a vector to raster. Yes, perfect, very good, because from Gdal vector to raster, you can go from shapefile to TIFF, but you can go also from shapefile to MV product, raster MV product, or ArcGIS raster. So of course, Gdal translate everything, but also the other tools are able to read the different format. Very good to point. So because the binding behind are the same. So if you need to change a format from raster to vector, you can go directly from shapefile to TIFF, or from shapefile to netcdf, because it's already inside. So you have to combine properly to have this kind of operation. Yes, please. Yes and no. You have to do it in two steps. So the question is, can I use it Gdal warp and getting the metadata of another file and then rasterize, warping my file in order to have a completely matching? In that case, I don't think they inserted, but in that case, what you have to do it? With Gdal Info, you get the pixel size and you store it. Then with Gdal source, this one, with this one, you get the projection information of your master file. And then with these two arguments, use Gdal1. And then it's going to be perfectly the same like you did it, okay? So the origin is based on the projection that he has, the internal projection. So, but you want to match a second projection based on a master file, let's call it. So what do you need? You need the pixel size, the extent, and also the projection information. So projection information you can get with this. Then you can get the extent and the pixel dimension with the Gdal Info, and then you can use it inside there. But this is what I was doing until a few years ago, maybe, and probably still the same, but maybe you have to see if they insert some kind of, please get all this information from a master file. Could be, eh? So for example, this one, this cut line, they insert very recently, seems no. But you can check it. Look, maybe it's this one. Yeah, so this one is when you have to define the source projection and the target projection. So over here, you should use it, the Gdal SRA info, so the project over there, okay? So it's again, sometimes you have to combine, quite often you have to combine a bunch of them to get what you want. We will see a bit of mixing between these. Any other question on this? Yes, Meg. I think it does to get in the main time, because when you do the projection, the reprojection, you need to know how to change the pixel value during the squeezing, okay, and the rematching. So you can search different, you can select different algorithms, nearest neighbor, cubic, spline. Now, which one is done first? I think they are done together, but you need to check the code to know which one is done first, because it's done in one single command, okay? No, okay, when, no, really the code, no, you have, because this one, all of them, most of them are in C++. So what you have is a binary file. Okay, so you need to go into the source of the Gdal command to understand and see the function that are not so easy. They are big scripting procedure. So all these one without extension are in C++, but there are few, like for example, Gdal proximity. Gdal calc is a .py, so it's in Python, and what is using the NumPy library to make operation between the raster. Okay, so they are really good. So this one you can open without problem. This one are already in your machine; they are not compiled, so you can open directly. So Gdal calc.py. You can see where they are. and then if you just click, you do more. So this is the script that is the gdalcalc.py. Actually, it's good because you can even modify this one to make a computation. So for example, this one is using Gdal NumPy to make 1 plus 2, the 2 band, and then is using Gdal and Gdal numeric, especially Gdal to read and write the matrix, and Gdal numeric also to make some computation. So any other question in this line? Okay, so in the same way that there are raster command, there are also vector command, okay, for vector file. There are mainly two that I use quite a lot. Gdal, sorry, this one, Gdal OGR Info for getting information about vector file, and OGR to OGR. So this is perfectly the same like Gdal Info, you get the metadata, and this one is for making cropping, reprojection of vector file, and so on and so on. So OGR Info, of course, you can get a lot of, from a shapefile. In the shapefile, there are not only geographic information, but there are also the attributes linked to the shapefile. So by using OGR Info, so for example, you can get the metadata. So for example, this one is giving to you, this is the file, this is the file, a vector file. I never use this format, but for example, is giving to me the list of the attribute where my global link ID is equal to this. So over here, I get first the information about the extent of the shapefile, and then the second one, I get all the attributes. So these are not actually, sorry. So these one are the coordinate, each single vector that you don't really need most of the time, but in the end, give you, or in the beginning, sorry, this one is giving to you all the information about the metadata. So we will see all these example in the exercise. And the same for OGR to OGR. So you can do the different kind of cropping a shapefile, a vector file, cropping in the meantime making an SQL query in the attributes. Okay, so you can do, okay, give me all the polygon that are area less than 200. In the meantime, cropping my stereo area. So it's very complex. So you have some function, and then you also have advanced option. Okay. Sometimes I didn't use all of them because they're really a lot, and they are keep adding some of them. So for example, this one was more or less in the line of your question, that you can click by using another data source, and so on and so on. So you need just to read and try to understanding what the software is doing. And again, down here there are few examples. Sometimes they're not very many. So for example, this one is target, so it's changing the projection. In the meantime, is clipping the destination based on this reference, X and Y coordinate. And be careful about this, super careful. And after year, I still making a lot of mistake, because the OGR to OGR over here, where it is the opposite. Output name, input name. Don't ask me why. Output name, input name. So it's the opposite. Okay, so be careful every time. OGR to OGR, remember that you have to do the opposite. Output first, and then, so target, destination, source, destination. And in the meantime, all the different advanced options. So with this one, you can do really, we will see example. You can do a lot of stuff in shapefile, you don't need to open and read the attribute. You can read directly the attribute in the terminal. So it's very handy to do this kind of operation. Have you, some of you use OGR to OGR in some case? Can you say for what? Yes, also there are also Python package for doing this kind of analysis, like GeoPanda and Shapely for Python. This one you can do really the pre-processing. Probably I would say that OGR to OGR is faster because it's in C++, rather Shapely is directly in Python. So maybe I would do it a bunch of data cleaning and getting small shapefile for what I need, and then I will do it in Shapely, and I will do it point interpolation and whatever I want, you know. So I always try to get the best from each single software in order to do clever computation and keep in mind also the speed. Meng, you were adding something? Okay. So let's go to the exercise that we will get the feeling of these tools much better. So I'm going to reduce and work in this way. I think will be fine. So I will have my, and I will copy. You can also open the script directly. So if you download the script over here I give you also the script that is already in the virtual machine. So you can even open RStudio, and RStudio has a R terminal, but also a bash terminal. Maybe I can even try. Let me see. So you can open a shell script also in RStudio, and you can have now I do it also for only for because I think it's quite slowly in my PC. So over here you have the console. Okay, so the default is the R. So don't start to copy paste bash in R because it's not going to work. But over here the terminal, this is the Linux terminal. Okay, so it's my black one. Whenever you click over here, you can write it directly. Okay, you can write directly to the bash terminal. So you can run also this command directly inside RStudio. So feel free to use it RStudio, but always keep an eye on what I'm doing in the visualization tools for plotting. They are not used because you can't plot something. So we will use another software to read and the real so I'm going to use this copy paste way to, but you feel free to use it RStudio. So let's move with the change directory. You enter directly in the folder that we are going to use it. So as you can see, these are all the paths, and it's very important also to use the bash command to see the path of your files and then copy paste in your R script, okay? So let's see a bit of what we have, first of all, in this data set, So for example, we have a bunch of files. So I'm going to list in all the folder, all the files that ending in .tif. So you can see several ones that are stored in the different folder. Let me organize it better. This one, okay. I think like this is even bigger. Okay, cool. So over here, I can have the different format. Okay, so as I mentioned before, before to even open any file, you need to get the metadata of your TIFF file. Okay, so in my case, I'm reading this TIFF file that is quite small. We will see what it is. So it's really small. It's really 700 by 600 row and column. Has all the metadata, all the projection information. And this one is giving to me immediately the extent, but also the pixel size, okay? Over here. This one give it to me the compression algorithm, so I can see that is a Gdal is a TIFF file that has been compressed, so very well. And this one is something that I want to point out, especially if you go in the direction of massive data process. So this is together with extent is something that you have to look carefully when you working with different tiles. Why? So first of all, this one is the pixel size, and you need to be careful and try to understand what does mean this number to have an idea in your mind. So anyone knows what is this number, where it's coming from? GeoGuy, 0, typical 0.08333. Anyone knows? Sorry? Yes, but is in lot long, so is a decimal part of 1 degree. Okay, but where is coming from? So if you, where is coming from? So it's coming from, what I have there. Anyway, I will type over here. If you have 120, sorry, 1 degree divide by 120, you get that number. That corresponds to 1 degree is more or less 112 kilometers. So if you divide by 120, you get more or less 1 kilometer at equator. Okay, so this is where this number comes from. Okay, so it's something that if you remember this number 08333, then you can derive in your mind all the pixel size in meter. So when we talk about 90 meter is 10 more. When we talk about 1 kilometer is this one. Okay, now it's a bit more clear where it's coming from. Okay, so something that you have to take into account is this. Especially make always this rounding number that create a lot of problem in the tiling system. Okay, because when I do the math, okay, I want to have a digital 33333, very long number. If I start to have this one in the middle of somewhere, and also over here, I don't have integer number, my tiles, they don't match. There is a gap between the two tiles, okay? So this is extremely important when you get the data in the massive data process mine to always check this information. Now we will see how to modify this information to have rounding number again, okay? With the Gdal edit, for example, you can edit this one. So you can already see, okay, I have this data, I can open, but I can already figure out that maybe this one can create some of my problems, okay? So even if you are entering R, it's better that you clean and standardize everything before with Gdal, and then you enter in R with your raster, because you have to do the prediction in R, for example, very well clean and tight. If not, you start to have this kind of matching pixel and it's not overlapping, one is bigger than the other. So spend a bit of time in this kind of pre-processing, please. Yes, perfect. Yeah, so the origin of this one doesn't give to it give to you the extent. This one is giving to you the pixel size, but the origin of the file is also based um, the on this number over here, the spheroid, and also the unit degree. So sometimes you have to check the origin if it's different or not. So you have to play with this number, and sometimes, look, if you just convert the pixel size to 333, you are changing, probably if you do the math, you are changing millimeters in your raster. Do you get it? No, just change it. Okay, make your life easy to have all the three over here, then not carry over this random number, yeah, this rounding of long number, because if not in the massive computation, then in the tiling system is going to be off and so on. So pay attention about the origin, pay attention. Then when you change projection, I don't use to change projection so much because I use it, I work at global level. And most of the time you get already lat long, but you guys that are working at state level, you have a lot of local projection that you have to match and combine. And that I know is a nightmare. So try and try and try until always find one data set that you consider your master data set, and then you merge all that one with the same pixel size, same extent, same projection definition, same origin. So always spend a bit of time before to matching everything. It's a really long procedure of trying and testing and so on. Okay, so the visualization of the bash inside to visualization of TIFF for raster file inside bash. So you can use it, of course, you can use it QGIS, okay, but I really like OpenEV. Nobody knows, and it's very old-fashioned software. I give explanation how to install it inside here. Install PKTools, OpenEV for the Linux virtual machine. You have it already, so we can run directly. And I would say that it's not a real GIS software. It's more a visualization software. But the beauty of these, that you see how it's pop up very fast, everything. So I can even close with a command line, and I can reopen directly. So of course I can zoom in, zoom out, something beautiful. You can see the pixel value over here down. Okay, so immediately you can go and understand your pixel value. You can have a bit of stretching of the color. You cannot make in fancy map. This is for fast visualization. Is my image full or not? You can go to the corner. Sometimes if you work with a filter, tiling system problem, you can go here and you can say, okay, let me see if my pixel on the border has been modified or has been cutted or whatever, you know. But the beauty of this is that you can use it in remote desktop. I didn't connect to the Yale server. Maybe I can do it this afternoon. So I can show you how I open images that are in the Yale server. And of course, you can open several images. So if you do vegetation.tiff, it's going to open all the TIFF that are inside there. So as you can see, I'm working a virtual machine, has been open all these TIFF that are not, look, they are like maybe 30, 40, nothing, in a few seconds. And over here, you can check one by one. You can see if they have been opened correctly. And of course, it's for this kind of fast visually. You can also open vector file, no problem, and they can overlap. You can open files that are in overlapping mode, like this one, but also in tiles. Okay, So I use it a lot for this fast visualization procedure. And again, it's really fast. Some of you have heard about this OpenEV. Are you going to use it? Okay. Of course, if you are inside R and you are producing a TIFF, no, because you have the visualization tool. But if you are in, like Tom was saying, you are in your processing algorithm and you pull out directly a TIFF from R, you run your full script, boom, that is producing TIFF. Then I open with OpenEV. Okay. If you have to make a fancy color and then so on, no, do it in QGIS. But this is much, if I run now QGIS like this, I'm not going to do it. If I'm going to do it like this, it's taking a while to open all of them. Okay. Okay, so we can keep going and see, okay, we already see these pixel size, minimum, maximum. How I can get minimum, maximum from the image? Anyone knows? Anyone go and check this fast Googling? How I can get minimum, maximum from the image? The first one tell me, get a beer from my side, on me. Come on, don't look at me, just Google it. Gdal stat, be careful, I don't want to use that one, and I will tell you, no, let's do it now. Status, bravo, I think it's plural, no? Okay, Gdal stat is giving to you minimum, maximum, but be careful, it's producing a file, that's why I never use it. It's producing this file, this one, okay, that if you change the file is not going to be updated. So you get again the minimum, maximum is going to be the old one. So don't never use it. Okay, so be careful that one. So, but in this case, the one that I was always use is the Gdal Info minus MM. So this one is giving to me the minimum, maximum. So this is the most important value that you have to read and check when you make a computation, especially if you have 20 files that you are producing. Are you going to open all of them and check if they are full or not? No, you can do minimum, maximum. Okay, I'm working with temperature, and my temperature in the globe is between 50 and plus 50. Okay, makes sense. If I get a temperature of 200 Celsius, probably is not correct, okay? So it's the minimum, maximum is the first stuff that you have to check in your image. And we will see how to do it in a batch mode. But something really important that I want to address this one is the data type. When I found this table, I said, finally understood what is this data type and how I can use it. And so I want to make bigger. So, and I hope that is going to be open your eyes also. Look, it's already open, the eyes. So who knows who are the data type and how to use properly? And in other words, the data type is this. So the value of in the image can have different data type. It's coming from how the byte are stored inside the image, okay? So you have different data type, and probably you heard the number, but then you didn't know how to use it. And I always use this table, and I have on my desktop because I cannot remember all this number. So there are different data type, and for each data type, you can store it a value, minimum, maximum value. So for example, byte, I can store it from 0 to 250. All my value need to be between 0 and 250. Unsigned, U stay for unsigned. Unsigned 16 can go from 0 to 60,000, 65,535. Okay? and so on. And then the different integer, all these one are integer. The one that are integer without the u, so integer 32, they can be negative value, okay? Negative value. And the one in float 32, they can have digital number. Okay, so be careful about this number in this table is extremely important for what? For this. Okay, size of the file. And then, of course, when you talk about the size of the file, you also talk about writing and read that file. If it's bigger, it's going to take longer in writing and in reading and in writing, okay? So as you can see, the same value, if you have a raster with value 1 everywhere, is going to be, so I can store it as a byte, and it's going to occupy 39, but I can store it also as a floating 1.0000. And how many zero is going to keep and collect? I mean, retain 38 zero. So you are storing all these numbers that you don't need it because you just need a matrix with 1 everywhere. So that's why it's important to store it and understanding from where to save it, okay? So for example, what I can store it in byte, land use classes from 1 to 12, I can store it here. Another one, how I can store Celsius, tell me. Celsius data. Sorry? Yes and no, do you need it? Let's see. Okay, so if you just need Celsius, first of all, you need negative because you want to go in cold region. So you need the one with the negative stuff, okay? So, but you need also the positive to have plus 50, 50, 60 in desert, in a Sahara, okay? So I would go and point for this one. Perfect. So, but then you say, I want also not only the integer number, but I want also the the digit after the dot. Do you need Celsius with 38 digit? No. Maybe if you do 2 digit is more than enough. 2 degrees and 25 probably. How I can do it? I just multiply everything by 100, okay, and keeping using this one. It's going to be 78 versus 300 double, okay? Did you get, so multiply your Celsius by 100, and you can still have, you know, over here, 50 for this, minus 50 for this one, and then the other 2 digit for your decimal. So always be careful and check it. And also this one, because if you have a floating point, and then you import this, that's why word clean has been multiplied by 100 for the same region. If you download word clean temperature, is multiplied by 100, if I remember correctly. And then if you have a floating point and you have to import in R, whoa, it's going to be an importing time very big. Okay, so always, always be careful. Meg, did you know about this? And sorry, which one? Int A8 is not compatible with the GeoTIFF. They don't use int 8. So so the data type recognized by the Gdal and the GeoTIFF community and so on, they are just starting from the byte and then they go directly to 16. So they don't have the 8. I don't know why. I don't know why. Yes, man. You know that I don't know this one. I never use it. I need to check it. I always use int32. I think this one is used it a bit in grass as a data type, but I'm not really sure. I need to go and check it, this one, but good point. They always, I never specify, and actually I never saw this one. Actually, this table comes from the R in Gdal command of grass. So probably is something over there that we need to read. Usually I always use this one, and so on. Okay. Some other question on this? Okay, so I want to also stress the importance of understanding no data value. For me, this one was really intriguing to understand what does it mean, this one. When I see, anyone has an idea? Okay, so this one is specify the no data value. Now one question, does tell us if there is a pixel or more than one pixel with this number? Yes or no? In the image? No, very good. It's just a label. Remember, when you see no data value is equal to, and there is a number, doesn't mean that that number is in the image. Okay? If tell you it's just a label, is a metadata outside to the TIFF, not in the pixel. Okay, so this is very important to understand, because all the pixel, be careful, label it as a no data that in your image with this number, if you import in R, will be recognized as an A. Okay, so if you don't have, if no data value is equal to -99, but your pixel value is this, R will not recognize. You have to define later. And again, this is another R action that you have to do inside R for modify your TIFF file. So more carefully you are on this, and less stuff you have to do it in R, and then everything is faster. So again, this one is just a label. Doesn't mean that the value is in the image. Let's try to open this image and let's see what I mean. Okay, so this is the raster file. Over here is a water, okay, and I specify my no data equal to this really long number. It, of course, has been truncated in the OpenGeoHub. Okay, so you can see down here, that's why it's also nice. You don't need to click, just pass and you can see this. Okay, now if you import this file inside R, it's going to be NA, no problem. And inside grass also, fine. Especially people that are working also with grass for ecological modeling. When you import it, this one will be recognized as a null automatically. So I can change that one with Gdal edit. Okay, so I can do Gdal edit minus no data Okay, now my Gdal Info is going to be minus no data 99. Doesn't mean that my pixel in the image has been changed. Okay, so here is still this big long number, but you don't have anymore the no data label over there. So now if you import this one in R, is going to be this long number. And of course, you have to treat that number not as a NA, so 2 digits, but like long string. Okay, is it clear? Okay, so Gdal edit. So Gdal edit, like I mentioned before, some of them in Gdal, some of them are directly written in Python. So that's why they have the extension .py. They are written in Python. So you can open and see, okay? Pay attention that now your minimum maximum is become different. Is this long digit. Why? Because the minimum maximum doesn't read the no data. But now, due to that you change the no data value to -999, now you can read in the minimum maximum this long number. So always play with this Gdal edit and no data to define correctly what you want. Because more are defined and better is than if you import it in R. So that's why super important, pixel size, extent, no data value, and data type. These are the 4 parameters that you have to really be sure that is as you want, as much as possible clean and light before to do any kind of operation with Gdal, with graphs, and with R also. And then your problem, they will become less and less and less, okay? There was somebody was asking question about the, yes, the computer. So over here, I can grep, and with the grep function, I can just retrieve the line that I want. In this case, there was the word compute, okay? And I can compute the line. This is really appealing because you can do also additional analysis in the, whatever you print is a text. So the text can be manipulated with, for example, with oak directly in the bash line. And this is what you give you the full power of Gdal, use it in the command line. So for example, if I do it oak, that for parsing text file, and I do print, and this one is column number, I want to, just the maximum, 1, 2, and 3, print $3. And it's going to give to me, forget it, it's going to give to me just, now it's computing, print $1, 2. Okay, so this one is there is the comma, so I need to specify that I'm using the comma as a field separator. So -f, comma, print $2. In other words, this is the first column, this is the second one. So now what it's doing is computing all the minimum maximum, but I'm going to retrieve only the command, or only the maximum. Okay, so this is very beautiful because with the maximum, then, okay, these can be the outliers, and you import it in R, and you do your analysis for the outliers. So you don't need, you import just what you want inside R, and then everything becomes super fast and clean. Okay. Okay, so of course you have to be smart and also willing to, eager to learn and check. So I give you a little exercise for you guys. For example, I want to crop this image. I want to crop this image with this value of coordinates. Which command of Gdal I use? So Google it and let me know. First, get another beer. I already give another one, so we have 2. We are running for the second one. Anyone? Any idea? This one, This one I don't think is working. This I don't think is working. Just wait. Okay. Yeah, this one. Gdal warp one, and the other one, another one. Perfect. So you can use two commands, Gdal Translate and Gdal warp. Be careful that this one in Gdal Translate, this ymin is called in the other way. So it's called in a different way. Gdal Translate is the in Gdal Translate is the upper left X, so it's going to be X min in Gdal warp. Okay, so in Gdal warp, but they are perfectly the same. I mean, they use for the same reason. So in Gdal warp, this X min is nothing else that in Gdal Translate upper left X. Okay, so be careful that this one I'll tell you the same also in this, but it's different the order. Okay, so here is upper left X, upper left Y, and so on. So they are swap each other. So every time try to see which one you want to use. In this case, it was perfect the same if you were using one or the other. Okay. Okay. So so let's move a bit on for the Gdal calc.py. So this is the typical command for making calculation between bands. Okay. There was one question there, please. Sorry again. You use XV. Ah, perfect. Yes, good point. Because in the shapefile, I mean, in the Gdal warp, there is the good point to address it. In the Gdal warp, there is the yes, there is the cut line or something like this, cut line data source that you can specify an ancillary layer, probably also another TIFF or only vector. I didn't use so much. I used it once, I think, with a vector file that you can use it cropping another one. So it's very appealing. So you have to pick up and read which one you want to use it in according to your request. And sometimes you can find the same tools in other in different command in Gdal, and we will see also in PKTools. Okay, so Gdal calc is for making band operation between the same, using the same file. So you cannot merge two files. If you have two TIFF, you have first merge and create two band. Actually, no, sorry, I make a mistake. You can also use two independent input and label it as file number A, so file A and file B. And then you can build up your operation inside to this line string. Okay, so this one is numpy string. So over here, if you want to do some particular operation, you have to use numpy functionality to do if condition, Boolean operation, mathematical square it to something. And the as type float, you will be sure that during the computation is going to be used float, doesn't doing any kind of rounding. And over here, you can also specify the data type. Did I specify? Probably no. Ah, yes. the data type is going to be float 32 as an output, but I want to be sure that also during the computation is going to be used floating point, because I'm calculating the coefficient of variation. So I want to have really precise number also after the digit, okay? And you can build up the typical band operation, file operation. You can also specify with the option Gdal calc. So, you can also specify which band are you going to use it with the option this one. So with the A_band number 1, you are going to use only the band 1 for that file. Okay, so it's very appealing, all the different stuff. It's not extremely fast because it's in Python. So it's good if you have tiles that are smaller, so not really huge, let's say maximum 10,000 by 10,000 pixel. So if you pass the 10,000 by 10,000, is coming sketchy. Okay, it's a bit slowly and so on. Again, NumPy in Python. Everything that is inside here has to be NumPy. So if you are searching for some mathematical operation specific, don't search as a Gdal. You have to search as a NumPy, and then apply inside here the NumPy operation. Okay. Okay, so the beauty of having Gdal directly inside to the bash, you can performing for loop operation for changing, for example, pixel size into all your data set. So, and for example, in the meantime that you change the pixel size, so you go from, you apply this pixel size, you can also crop it. Okay, so this is the beauty that for all my TIFF, Landsat image, LST, land surface temperature, I'm going to crop it, my steady area, and I'm going to compress. This is the compression algorithm that I usually use it. It's one of the most compressed and fast. So I just use it this one always. And I'm going to call all my file .crop. So you can see, you can copy paste these. And it's going to loop through all the image and cropping all of them. Okay, so very super handy. I'm going to see all of them cropped very fast. You don't need to wait a lot of time. I can open all of them and see, okay, has been cropped all of them? Yes. So as you can see, I open it all of them by just, and there are a lot. With OpenEV, I open all of them. I can see that has been cropped all of them, and I can check and so on. So this one is quite appealing. Okay, so this is something that somebody of you and asked me, and also several of you already did it. So can I get, is always a request, can I get the pixel value in one specific point? And this point can be identified by the position of my row and columns, but also as a lat long. GBIF data of the data set that Tom was using today could be extrapolate by Gdal allocation info. It's going to be extremely fast. So for example, if I loop to all your image, my image, and I want to get all the pixel value at location 20 by 20, okay? 20 by 20 is my pixel and row, but I want to get at this coordinate, 32 and 2. Okay, so this is given to me, and in my case, the 32 and 2 are my degree, is my coordinate. So in this way, the geoloc flag give me information about that I'm going to use lat long, and the val only is giving to me that I want also only the value. I don't want to the other metadata information like this one, location band 1. So I just want the data. So in the same way, for example, if I have a little file that I can create just as a fake one. So if this one is my super big, this is very appealing for all of you. I have a big file with my point coordinates, okay? So the 2 billion points that Tom was showing to you, I would go and extract immediately like this, okay? So suppose this one is very long, so you can passing this file to the Gdal location info, and is going to give you for each layer your value for the 2 point. Okay, so this function is usually done with the function extract in R that is very long. Okay, if you do it in Gdal with Gdal location info, magic, super fast. This one, 2 billion lines, no problem. Is going to create this file. Okay. If you give more than one, if you give over here, be careful, guys. If you give over here a VRT file with all the band, okay, is going to give you for all the band. So now I have only one band, one TIFF, one band. But if not, it's giving to me all the band. Okay, so in reality, you can passing through a very big VRT file here, and is giving to you all the file, and it's super fast, really efficient, and so on. And then, for example, let's do something like so you can have the value over here. There are also way, of course, you have to manipulate with bash. So for example, I don't want only this one. I want also the lat long. So you have to play a bit in order to have it. Now, maybe like this. I say something that I need to show you. I think like this can do it. Cut. Here you have it, okay? So maybe take a note of this, that is a bit tricky and not so easy. So again, is a bunch of bash manipulation in the text file, then you can retrieve it and build up this huge table for your machine learning, okay? So play a lot of, and you can use, for example, this one, for example, is to give the intermediate life, so I can take it out and you can have the full table with X and Y for each one. So you can merge and build up your table like this. Question mark. So the paste over here. Question mark. In the for loop, sorry. Okay. So over here, the question mark identify the list of variable, list of file that I'm going to use it, okay? So over here, by the question mark, I can put one question mark is going to be select all the file with one, okay? And the other one with two question mark with the 2 digits. Okay. So if I, okay, so in this case, I'm going to list the first from 1 to 9 because I put as a first. Actually, if you do like this, you can see in order. Actually, it's not doing, it should be the opposite. Strange. I know it's not listing, it's changing the listing. Anyway, if I can list the two value with one question mark, the only one digit, the two question mark with the two digit. I can also put the asterisk to everything, but in that case, I was getting also the crop. So I was just use it, the one that I want. You can use different one. You can use also this kind of, these are called um, special character or special expression in Bash. So you can also use it from 1 to 4. Actually, from 1, yeah, 1 and 4 is going to select only 1 and 4. And I think you can do it, but it didn't give me, maybe it's another one. You can do also from 1 to 4. I don't know which one is. You need to check. So these are all the meta character. This is how they call it, meta regular expression. Meta character and regular expression in Bash, you can see all this information. So this is really appealing for you guys that are always drilling point location information in the raster. Some people that were doing the hackathon, they were asking me, NetCDF, can I drill it one point and getting the information of that point? Yes. So with this Gdal location info, you can do it. Okay, you need to play and then build up your table because you need to do a bit geek in writing this kind of Bash syntax, but it's still the fast way to go. So I want to also stress the emphasis, and this is for conversion from an image from text, yes, from image to text and from text to image, okay? It's not something that from a computational point of view, if a computer science was here, was going to be killing me, okay? Because it's very wrong to do this kind of stuff because a TIFF is a binary format, so it's much faster than a text file. Text file is not binary format, so it's not compiled. That's why we can read. So every time that the computer is going to do something, it's going to convert in byte and then do something. So the text file is always slow and occupy more size compared to a TIFF or, yes, a compressed. But this is how you convert a file, a TIFF file from X, Y, and Z. So by this, you can convert your file, and now your file is going to have lat long and all the pixel over here. Okay, this is quite appealing because sometimes you can do. There are, again, big image, you want to know if all your border of your image are fine. So how you can do it? You can select this one, and then if now I want to select all the pixel in this coordinate, I can do it, okay, give me everything in that corner. I can see, okay, these are my value of my pixel, so there is no any zero, so it's fine. So sometimes you don't really use this one for the computation, but for checking. Okay, so it's very important to go from image to text file to be able to read and see. You cannot open one by one the image. So you need to some smart way to read. And also because this one is a text file, okay? So I can manipulate this text file with Bash. Okay, so I can manipulate this text file with bash. So for example, I can do it. I want to change my third column, so this one, when I met this condition, all the number bigger than 2 and all the number less than 4, please print 50. If not, print the file. So now if I run this line, okay, so if I run this line, I can see that over here, my pixel that matched that condition become 50. And now I can reconvert back my image. Now I can recreate my image. No. Okay, so this one is going to be my image that has been cropped, change the pixel value to 50. Now if I open it, I can see that some pixel over here, they become 50. Is the way to change the pixel file? No, don't do it, okay? This is just to demonstrate how you can play with a text file and changing and operate from image to text file and so on. We will see in the afternoon a clever way to do it for changing the pixel size more carefully. But these are very important tools for for diagnosis of your image without open one by one. So and try to understand where you can another really appealing file format and that is supported by Gdal is the VRT, that stands for Virtual Raster T, I don't know, tiling, Virtual Raster tiling. Any one of you use VRT? VRT, two people. So VRT is really great because it's not a raster file, it's just text file that is pointing to raster file. Okay, so I have 10 tiles over here. I can create a T file, a VRT file, that inside to this VRT file, there are hyperlink to each one of these TIFF. Okay, and it's giving me to the path. So for example, if I run this view line, I can see that I create a stack file where I combine, where I get the different file, two files over here. Okay, so as you can see, it's very fast because it's not merging. It's not Gdal merge. It's just hyperlink to the file. If I get a Gdal info, it's going to tell me, first of all, here in the top, that is going to be, I have information about, need to go up too much. So it's going to give me information that is going to have two files as a hyperlink, and also that is giving to me Gdal info. Yes, that is giving to me, for example, the band 1 and band 2, and of course, if I get minus mm, I can get also the minimum maximum of the two band. Again, is a virtual file. It's very small. It's few byte, very small. So it's very handy to do this kind of pre-processing, and I can use it inside Gdal. So for example, I can use it now, and this is how I do the tiling system. When I say I'm tiling my image, I do it in this way. After that, I create a VRT. I can split based on the dividing my image in 4 big tiles. And then over here, each one of these is going to be my quarter of image So this one is going to be just 1/4 of the image. Let me put one of these. And that one is going to be just 1/4 of my image with, of course, what? With the two band for each file, because I first merged it. Okay, so this one is opening, and you can see, okay, probably I make some mistake in the path. So here is the big image. So my image is going to be divided in 4. Let's see if I can open it again. So this one is always good. It's missing vegetation. Yes, now it's going to. Okay, so, and here I can see one of these is going to be just 1/4 of the image. Let me see, I need to zoom out. Here you can see that this is the upper right corner, okay? So this is how you, with the VRT, you play. And the beauty of this, that the VRT file, so this VRT file can be read by Gdal, and we will see can be read also by PKTools. So several steps, you don't need to create several TIFF. You just create a VRT that is point to another file. Please. Perfect, good question. So you have two options. When you do separate, be careful about this. When you do separate, it's going to pile it up as a band, okay? So use this one just when all your files, all your tiles are belong to the same study area, like in this case, okay? If you don't use this one, pay attention. If you don't use this one, it's going to not do it like this, but it's going to do in tiles. Of course, this one needs to be with different projection, okay? So what is happening if they are in overlay for composite? If you then you change the VRT, you transform to TIFF, it's going to take the first one on top, okay? But if there are no data, then it's going to, so if there are ones that have been up here that are no data, then it's going to take the first one with the data value. So it's very good for making composite, but you cannot select if you have more than one layer with the data. So if you have 2 layers with the data, you cannot say, give me the mean or give me the maximum. It's going to just have transparent action for the no data and on the first one. We will see in the afternoon as Gdal composite can make, sorry, PK composite can make composite in a more clever way than using build VRT, okay? So you can do the composite, but remember, it's going to take only the value on the first. If it's no data, it's going to be transparent. So for some case, I use it. I do the composite in this way. If I don't have to do any kind of vertical pixel aggregation, that's cool. Okay. Very good question. And can be also used in the opposite direction when you have the tiles, like we mentioned. So in this case, we have my 4 tile, and I want to recreate back my TIFF. So you do the opposite. You do build VRT, you give the 4 tiles, you create the VRT, and then this VRT you transform to TIFF. Of course, with the compression action and so. And of course, over here, you can do a lot of steps with the tiles. Okay, so that's why it's very important to have really this extent really well defined. Okay, in this case I use pixel, row and column pixel, but you can also use degree, lat long, okay, or meter if it's UTM. So you need to specify better proj win over here, but it's the same concept. So the build VRT, you can also use it for intermediate step. Most of the time use it before to do the full processing and so on. So you can really nest it a lot of function and create VRT without really producing the file, you know, the TIFF file. Okay. Something that I also use it in combination with, maybe this one is quite new, is this Gdal tile index. After that you can create a VRT file as a file, you can create a shapefile with a border of this file. Okay, so this is very appealing for this context. Okay, so now this one is going to be a shapefile with a border of my tiling system. And this is very nice because you can see even without open the image. So, but just open the shapefile that you create, if you have gap between the, okay, sorry. If you have gap between the tiles, so if you zoom in a lot, okay, I did too much fast. If you zoom in and you don't see any problem, you don't see any gap between, means that all the extent they were really matching. You don't have this pixel border effect. So this is, I use quite a lot as a final check when, especially when I tiling the image, if I tile it correctly, if someone is missing, and so on. So I really use it a lot. You have also some other command like Gdal proximity to calculate buffer. Okay, so this was adding like probably 2 years ago. So like you can see, they are really evolving. This is a Python one, so it's quite it's not super fast when you do it with a very huge data set, but if you tiling correctly, then it's going to be fine. And here you can see the proximity index, proximity with a typical buffer. These are for stretching. Sometimes you don't see the image, but then if you stretch it, then you can see the buffer, so on. So for example, the workshop that Tom is doing the other side, where he's using the index distance, the proximity, the distance between the point to give spatial information in random forest. You can do it by here, OpenEV. Okay, so this one is giving to you distance through the point, so it's really appealing for this test. You can do with the Gdal dam, you can calculate the slope, you can calculate the aspect, you can calculate terrain roughening index, the one that I showed to you, topographic position index, different, and the roughness. So these are the main roughness index that are present over there. And so on. There are much more. I present again. If you go over here, you can have a full list of the raster command. Oops. Of the raster command that you can check, and you can do a lot of preprocessing. Just you need, for example, this one near black, I never use. I just read now. Convert near black white border to black. I don't know. Need to be checked. So they are keep adding stuff. And when I started, there were 3 of these: Gdal Info, Gdal Translate, and Gdal Warp. That's it. So that's why it's good to have to see how they are dynamic. I mean, and there are the people behind the Gdal Warp are really super clever coder, and they are amazing community, and they keep running the geographic information system in the background of all the software. Last section that I want to cover for these few minutes that I have is the Gdal command, OGR command. So the same way of doing stuff in raster, you can do it in OGR. So for example, OGR info give you information about the attribute of this shapefile. Okay, so these one are the attribute, but they are the shapefile with the name of the attribute. Okay, with the information in the attribute table, a so-called attribute. Can I extract all? I want to see all the attribute table, the name of the country. Yes, is a bash text file. I can just do pipe grep name, enter, and this goes to me the list of all the attribute name in that file. Okay, so it's really appealing to, okay, how many I have? WC minus L. I have 247 countries in the world according to this. Then so you can really checking. I don't know if they have also some other information that you want to grab, like, okay, which one, I have the area, which one is the biggest? I don't know if it will give them to me. Grep area. Okay, so I have several files with the area. I can sort it. Minus G give to me the ordering, and minus R is going to be the biggest, is going to be on top. So it's mine, this one. So this one is going to be the country with the biggest area, and then again, even manipulators. Okay, I cannot see now which country is. I know only that it's big like this. So you have to keep play to extrapolate also the country. So, and this is the fastest way to read attribute in the shapefile and manipulate and do this kind of operation. Everything that you print in the terminal, you can manipulate afterwards. Remember, if it's a binary, you create a TIFF. No, you need something else. But if it's printed in the terminal, then you can manipulate it. So it's a matter of understanding how, okay, and create this table that later on you can do the operation. So, and of course you can also create some kind of query inside with OGR to OGR. So for example, select all the shapefile that have the name Uganda. Okay, so be careful about this. Is always complain if you don't remove the file. So you can do OpenEV. And you can see that I select is opening, is a big file because it's a country border. And you can see that I select in a very fast way Uganda, just creating a shapefile. Then this shapefile I can import in R is going to be super clean and fast, okay? So this is the kind of operation that I suggest to do it. And you can do also something more appealing, you know, like calculate a new value inside the attribute table by adding a new column. So just making some operation in the attribute table. You can do SQL statement. So select from all the country, having an area bigger than, so it's a matter of play a bit with this operation. And really it's very fast. I never had any problem of crashing, or maybe it will take a while, but we'll do it. Okay, they're not all these one GDAL and PKTools also. The beauty is that they've been built up with the memory constraints, so they never fill it up the RAM. So they're very good when you do a multi-core processing, that you can go in multi-core, because you can have the multi-core, but the RAM is one. If one core is filling up the RAM, the other core, they cannot run. Okay, so then you're freezing and you go into swap memory, it's going to be super slowly and it's also crash. Rather, GDAL, you can use all the core because the RAM will be always quite enough. Okay, so it's very appealing in this context of multi-core. Okay, so this is what I want to cover, everything. For the people that were following me online, I can also give you a few tips about spatial ecology. Over here, there are, in the main page of the DokuWiki, now it's coming, zoom out. There is over here, there is a lot of, especially people that want to go in this super massive data process. I suggest this one, cluster processing, and also language integration. So these are really the big core of this multi-language interaction. And if you go down over here, okay, you can see the material of this one. And you can we have also a YouTube video of this one, especially if there were some Zoom problem. So we will check if the live streaming was going correctly. If not, we can use the old one. And we are going to meet at 2 o'clock for the PKTools, that we can see what Gdal cannot do, it can be done by PKTools. And of course, I will be around for questions, or even now if you have more questions. Appealing? Ready to use it?
Is there a way, how do you integrate with Gdal on Windows?
Don't do it. There is no, there is, it's called the it's called, there is a package that you can install it, but then you can run each single command in Windows, no problem. But then you don't have the bash functionality to do this kind of interaction, you know. You can also do a for loop in Windows in the command line, or in the commander of Windows, but you don't get the full power, you know. So it's better to use the OSGeo that is already there, and learning a bit of bash and having the ability to combine all these tools. Yeah, bravo, very good. Yeah, so if you do R, there is a system, it's called system, no? So if you do system, open and close, and over here you do Gdal Info, and then you put your input.tif. Okay, now I don't have the input TIFF, but if you do like this, it's going to print over there in R so you can do your string manipulation inside R. Over here, this one is going to be done by Gdal, no problem. But what you are printing in the terminal is going to be treated by R. That's good, but be careful because it can be big. Okay.
Just a point about Gdal in Windows or Linux pure. You can do it. You need to just install Gdal on Gdal. But fair warning, as soon as you do it and you try to run it, you will get off variable errors and environment variable errors. You need to set that up for yourself. It's not in OSGeo. You need to provide info where all the stuff that Gdal needs is, and then you can do that.
We already installed
Okay, very good. Additional question? Another one? Then I go to the, actually, let's go first this section. If not, I'm always there. Meng.
I'm just wondering, create public visualization,
Where? I mean, OpenEV, you can call it through Bash, like I mentioned to you, but so like this.
but this is not a command.
Sorry, this one is a command. OpenEV is a software that you can open directly through Bash, but is not in the terminal. The terminal can only open text file. So you need always the X11 for Word, they call it, to open an image. So, or you mean something else?
Yeah, like there's some feature, something from the page. This one is not command.
So you can visualize something. The only thing that you can, let's call it visualize inside Bash directly, are text files. Okay, so the text file can be open with more command or with less command. Okay, so if I, let me see, txt. So here I was creating some, okay, now I give you a very nice example. So if I open this one, that is a text file, check it out. Okay, I see the number. If I open a binary, I see this one. That is the binary format that cannot be read by humans. Okay, so you can't open T for shapefile directly in the Bash terminal. You need an ancillary layers, an ancillary software. Yes, I install it in the virtual machine, so you can use it, or especially for the people online, you can use the, over here I put how to use it, how to install it for the in the virtual machine. Is it clear? So over here you can go here and you can install OpenEV and see how to install it. You don't have a tools like RStudio where you can plot it there. No. You can't. You can't do it. You need always something ancillary to open it. Okay, so I will be around for other question, and this afternoon I go to the other room. So come to the other room. Okay, perfect.